Alright, so the next couple of videos we'll work through our test on Unit 10. So the first couple concepts that we've talked about in this unit are how to determine what type of sequence we're dealing with, whether it's arithmetic, geometric, or neither. So if we look at number one here, let's see if there's a pattern. It looks like we're increasing each time by 6. If I keep adding 6, that's how I'm getting each of these subsequent numbers. So that means that we're dealing in this case with an arithmetic sequence, because arithmetic means that we're increasing by the same amount each time, by adding and subtracting, that is. All right, number two, it looks like we're going from 3 to 5, we're increasing by 2. If we go from 5 to 8, we're increasing by 3. If we go from 8 to 12, we're increasing by 4. So there is a pattern here, but it has to be going up by the same thing each time in order to be arithmetic. So it's not arithmetic. It's also not geometric because we're not multiplying by the same number each time. There's nothing that you can multiply 3 by to get 5. That's the same number that you could multiply to get 8. So it's actually neither arithmetic nor geometric. All right, number 3 and 4, we put the formula right there. That's the, here they're asking us to find a term number for, in these cases, we're dealing with arithmetic sequences, because to go from 5 to 8, we're increasing by 3. To go from 8 to 11, we're increasing by 3 again. So this is clearly an arithmetic sequence. We want to find the 39th term. So that means we're going to go to this formula. We're finding a sub 39, and that's equal to the first term, which in this case is 5, plus the common difference, which we found out is 3. And then we're going to multiply by n minus 1. Since we're finding the 39th term, we have to increase by 3 38 times. And this is going to be 5 plus 3 times 38 is 114, I believe. And when we add those together, we get 119. That's the 39th term. All right, number 4, they want us to actually find out what this formula is. So our nth term is going to be our first term, negative 15, plus our common difference. And it looks like each time we're increasing by 10. So the common difference is 10, times the n minus 1. Because if we're finding the nth term, we always multiply 10 by n minus 1. The only thing we can do here to simplify a little bit further is distribute. So 10n minus 10 is what we get. And then this is going to be a sub n is 10n. And then we have negative 15 minus 10 is negative 25. So there's our explicit formula for that. All right, numbers 5 and 6. On number 5, they give us two terms in a sequence, and they ask us to find the common difference and the explicit formula. So let's first find the common difference. We're going from the 15th to the 38th term. So from 15 to 38, that's a distance of 23 terms. And in that distance, we're going from 7410 to 2810. So how much distance are we covering in 23 terms? It looks like we are covering 4,600. That's the difference. So I want you to think about this. If you're going 4,600 and you're doing that in 23 terms, how much are you going each term? And the answer would be you just have to divide these. If I'm traveling this distance in 23 terms, that means I'm going 20 each term. That's our common difference. Okay, so we're being asked to find also the explicit formula, so that's this right here. So the explicit formula will be a sub n equals our first term, and we don't know our first term. We'll find that in just a sec. We do know our common difference, though. How can we find the first term? Let's just take either of these two. So let's take 15. So a sub 15 equals, we don't know the first term. We do know that n minus 1, if we're finding the 15th term, we know n minus 1 is going to be 14. And we know the 15th term. The 15th term is 2810. So all we're doing is just plugging in information that we know. 20 times 14 is equal to 280. So now all we have to do is solve that for a sub 1, and we will pretty much have our answer. So we'll subtract 280 from both sides. 2810 minus 280 is 2,530, and that's our first term. So our final answer here, a sub n is our first term, 2530, plus our common difference times n minus 1. And again, we could distribute if we want to, so this comes out to be 20n minus 20. 2530 minus 20 is 2510, and then we have that plus 20n right there. And so this is our a sub n. That equals our explicit formula for that. All right, number 6, find the missing terms. This is very similar to what we did right here. We found out the distance we traveled divided by the number of terms. So first, what's the distance from negative 8 to negative 38? We're going negative 30. Right, if you're not sure how we got that, negative 38 minus negative 8, that's another way of saying what's the difference, and that's equal to negative 30. So how long did it take us to travel that? Well, we went 1 term, 2, 3, 4, 5, in 6 jumps we went negative 30. So that means we're going negative 5 each time, negative 30 divided by 6. So let's test that. So if we keep adding negative 5, that would be negative 13, plus another negative 5 is negative 18. Plus another negative 5, plus another negative 5, plus another negative 5. And here's the way to check that we did it correctly. If you add another negative 5, you do wind up exactly at negative 38. All right, so now we're going to talk about evaluating arithmetic series. And we have our 2 formulas right here. We can usually decide which one we want to use, but I'll tell you for number 7, this one is going to be easier. Why that one? Because they're giving us n. They're giving us a1, they're giving us an. So all we want to do is plug this in. So we're finding the sum of the first 40 terms, because they're telling us n is 40. That's going to be n over 2, which is 40 over 2, times the first term, a sub 1 is 46, plus, and again I'm using this formula, plus the last term, 436, and now all we have to do is simplify that. So we're going to get this. We'll get 40 over 2 is 20, in parentheses 46 plus that is 482, and then 20 times 482 is 9,640. That's the sum of that series. All right, the second one, let's practice using the other formula, so this time this one, okay, because this one is easier to use when they're giving us a1, because we have d, which they're giving us here, and n, which they're giving us right here. So that means the sum of the first 14 terms is, I'm going to put a 14 right there, 14 over 2, box this off for a sec, 14 over 2 times, and then we have this big parentheses times 2 times a sub 1, which is 36, plus d, and they're telling us d is 10. Again, we're using this formula, we're just plugging in what we know. And then n minus 1 would be 14 right here minus 1, which is 13. So then we get 14 over 2 is 7, and then in parentheses 2 times 36, 72, plus 10 times 13 is 130. That's going to come out to be 7 times 72 plus 130 is 202. And then when we multiply that, we get 1,414. That's the sum of that series. All right, numbers 9 and 10. Number 9 says the same thing, evaluate each series. Well, this time we have a choice. We can really use either of the two. I would suggest this one would be easier. And the reason this is easier is we have n, we have a sub 1, we have n, and then d will be easy to find looking at this, because you can probably look at it and tell, what are you increasing 8 by to get 16, or 16 to get 24? You're increasing by 8 each time. So we want to find the sum of the first 15 terms, because they're telling us n is 15. That's going to be n over 2, so 15 over 2, and then times 2 times a1, a1 is 0, plus, right here it says d times n minus 1. So d, we determined that d was 8, and n minus 1 is 15 minus 1, which is 14. So I'm going to keep this as 15 over 2 for now, and you'll see why in just a sec. 2 times 0 is 0, so that just doesn't even need to be there. And then 8 times 14 is 112. Why did I keep it as 15 over 2? Because now you can cancel 2 going into itself once. 2 goes into that 56 times, so you're left with 56 times that, and that, I believe, turns out to be 840. All right, the last one for series would be using sigma notation. And it doesn't really matter which formula we use. Let's just use this one right here. So how many terms are there from 1 to 50? There are 50 terms. So we're asked for the sum of the first 50 terms. That's 50 over 2 times the first term plus the last term. How do we find the first term? We plug in this number. So let's plug in m equals 1 right here. And 5 times 1 is 5, minus 15 is negative 10. Okay, then we'll skip ahead to the 50th term, because that's all we need for using this formula right here. The 50th term we'll get by plugging in that top number right here, which is 50. Plugging in right here, 5 times 50 is 250, and 250 minus 15 is 235. So now we have our a sub 1 that goes here, because that's what the formula says, plus we have our a sub n that goes right there. And now let's simplify this a little bit further. So 50 over 2, this right here is 25, and then negative 10 plus 235 is 225, and when you multiply those together, you're going to end up getting I believe 5,625. If any of these answers are wrong, it's because I'm doing it off the top of my head with no calculator, but I believe that should be correct. So that is the first 10 questions. The next video will continue.